in the triangle congruence SAS lesson, they talk about the side angle side congruence postulate. And what that says is if two sides and the included angle, which is the angle in between the two sides that you're talking about, are congruent, then the triangles are congruent. So what it means to be an included angle. So if you are trying to prove triangles are congruent, using the SAS, you only need 3 things. You have to have 2 sides that are the same, and 1 angle that's the same, and automatically all the other parts of the triangles are the same. But it doesn't matter what sides they are, but it matters what the angle is. So if I knew these 2 legs here were the same, and these 2 legs were the same, for us to use SAS, we would have to know something about the angle in between them, the included angle. Okay, so you can't use one of the ones on the outside. It has to be the angle that touches both of the things that I highlighted. If it was this one, we'd only be touching the blue. If it was this one, we'd only be touching the pink. You have to be the included angle touching both sides that you're talking about. So I put a proof on here just to kind of give you another example. It says, given segment AE is congruent to segment CE. So we are given that these 2 are the same. And then it says E is the midpoint of BD, and we need to prove that triangle ECD is congruent to triangle EAB. Okay, so like I said, when you're doing SAS, the side angle side, all you need are 3 things. That's it. 3 things are congruent, and boom, your triangles are congruent. Now it does matter which ones, so let's start getting some stuff down here and see which things we need. So our first statement, remember you always start with a given. Segment AE is congruent to segment CE. Two, E is the midpoint of segment BD. Okay, so once you list the given, you need to use that to get other congruent parts. So this first one, AE is congruent to CE. Great, that's super easy. We got a congruent statement from that. Now from the second given, it says E is the midpoint of BD. Is there a congruent statement that we could make from that information? If E is the midpoint of this segment, midpoint means you're cutting it in half, perfectly in half. So if the whole thing was 10, it would be 5 and 5. So what that means is this midpoint makes BE congruent to DE. Remember that order matters in the way you name things. So BE, DE. So from this statement here, I got another congruent statement that BE is congruent to DE. And that is the definition of midpoint. So it means to be a midpoint, cuts things in half. Okay, so now we've got 2 things. We've got 2 sides, and we need the third thing. So we've got here, and we've got here. So if we want to use SAS, it has to be the included angles, so the angles that are in between the 2 sides. So we've used up all the given. So from there, you just have to look at the way the picture looks. So I need to say something about these 2 angles here. So the way these pictures are drawn, we can actually tell that those are vertical angles because BD and AC are perfectly straight lines, and we know that vertical angles are the same. So I can say that angle, remember order matters, so I'm going to go along the pink and then across the blue. So AEB is congruent to angle, start at the pink, CED, because they are vertical angles. Okay, so now we have our 3 things, 1, 2, 3 congruent statements. Now I can say that these triangles are congruent. So this tells me what to write last. So I can put triangle ECD is congruent to angle EAB by SAS. So some tips and tricks that might help you go through your proofs. Like I said before, always start with what you're given. This always comes first. Then if it's not an actual congruent statement, like this is a plain congruent statement, we got it, great. if it's something like this, like E is the midpoint of BD, what you need to do is try to pull a congruent statement from that information. So what we did is E is the midpoint, therefore BE has to be congruent to DE. Some other examples or information that you can use is also the way the pictures are drawn. So like here, because we had vertical angles, we could use that. So some other things that you might look for when you're looking at the picture, and you've used your given and pulled a congruent statement from everything that they gave you, look for overlapping sides. So if the triangles are touching, so for example, DAC and BAC, they both share this side AC, right? So what you do when that happens is you use the reflexive property and you say that AC is congruent to AC, which makes total sense. Of course, something is congruent to itself. So if you ever see overlapping sides on your triangles, use the reflexive property. The second thing you need to look for are if they tell you the lines are parallel. When you have parallel lines, you're either going to use corresponding or alternate interior angles are the two. So this one, here are our parallel lines. If you were to extend them, they would be like this. It is cut by this transversal BD, if I were to extend it. So right here you can see we have alternate interior angles, and alternate interior angles are always the same. So angle angle ADB is congruent to angle CBD. The last one, like we used on our proof a couple of minutes ago, is if they give you the midpoint. When they say, like here, C is the midpoint of AD, that means that AC is congruent to, I put that in the wrong order, DC. AC is congruent to DC there.